Series circuits. If one device fails in a series circuit, current in the whole circuit ceases and none of the devices will work after it. If 3 lamps are connected in a series with a battery, they form a series circuit. It doesn't have to be 3, it could be 2, could be 1. Charge flows through each one in turn. When the switch is closed, the current exists almost immediately in all 3 lamps. The current does not pile up in any lamp, but it will flow through each lamp. Electrons in all parts of the circuits begin to move at once. Eventually, the electrons move all the way around the circuit. A break anywhere in the path results in an open circuit, and the flow of electrons stops. Burning out one of the filaments, or simply opening the switch, could cause a break. And remember, if there's a break in the circuit, then electrons aren't going to flow. Alright, so here we have a series circuit. We have a 9-volt battery and a switch. So the electrons are going to flow through the switch. Right now the switch is opened, but if we close the switch, then the electrons can go through each one of these bulbs. This is in series. The electrons don't have a choice. They have to go through each bulb, giving a little bit of their energy to each one. And remember, they're going to split up that energy equally. So all 3 of these bulbs will be the exact same brightness, as long as they're the same exact light bulbs, which it sure looks like it. So this is what it looks like in real life. This is closer to what we use in physics, engineering, electricians, closer to what's called a schematic. Though instead of light bulbs, there's usually little symbols, and instead of an actual battery, there's a couple of lines here to represent the cells. For series connections, electric current has a single path through the circuit. The total resistance to current in the circuit is the sum of the individual resistances along the circuit path. So what that means is if each of these bulbs had a resistance of 3 ohms, then the total resistance for this entire circuit is 3 plus 3 plus 3 is 9 ohms. You just add them all up when you're in series. And you know you're in series because the electricity has only one path to follow. The current is equal to the voltage supplied by the source divided by the total resistance. This is Ohm's law. Ohm's law, as long as all temperature remains constant, is V equals I times R. V is our voltage, our potential difference, I is the current, and R is the resistance, total resistance for the circuit. So V equals I times R. The voltage drop, or potential difference, across each device depends directly on its resistance. So as the electrons go through here, remember, you go through the battery to get your energy, and then you come and you give your energy here. And as you give your energy, you're dropping in some of that potential. So you get your potential, electric potential, and then there's a drop in potential, drop in potential, drop in potential. That depends exactly on resistance. The sum of the voltage drops across the individual devices is equal to the total voltage supplied by the source. So that means the voltages are going to be split up. This is one of Kirchhoff's laws. So if this is a 9-volt battery and there are 3 batteries, then I know this battery is going to have a drop of 3 volts, and this is going to have a drop of 3 volts, and this light bulb is going to have a drop of 3 volts. So if you imagine taking 9 pieces of candy from the battery, coming around, giving 3 pieces of candy here, 3 pieces of candy here, 3 pieces of candy here, each one of those light bulbs is going to be the exact same brightness. They're going to have everything exactly the same because we're in series. It gets a little bit different when we're in parallel. The main disadvantage of a series circuit is when one of the devices fails, the current in the whole circuit stops. Some cheap light strings, like Christmas lights you might find at the dollar store or something like that. When one lamp burns out, you have to replace that lamp. Otherwise, none of the lights afterwards are going to work. It's kind of annoying. A series circuit is like a single lane road with no alternative path. If there's a roadblock or a cave-in, traffic is going to stop. If one goes out, they all go out. Pause this video after reading this question. What happens to the light intensity of each lamp in a series circuit when more lamps are added to the circuit? Pause, think about it, write down your answer. Answer. The addition of more lamps results in a greater circuit resistance. The decrease in the current in the circuit and each lamp is what causes the dimming of the lamps. Here's another one. A series circuit has 3 bulbs. If the current going through one of the bulbs is 1 amp, can you tell what the current is through each of the other 2 bulbs? Next, if the voltage across bulb 1 is 2 volts and across bulb 2 is 4 volts, what is the voltage across bulb 3? The same current, 1 amp, is going to pass through every part of the series circuit. Each coulomb of charge has 9 joules of electric potential energy. 9 volts equals 9 joules per coulomb. The definition of a volt is just joules of energy per charge. If it spends 2 joules in one bulb and 4 in another, it's got to spend 3 joules in the last bulb. 3 joules per coulomb equals 3 volts. So when you go through a circuit and you add up your potential difference gain, which in this circuit is 9 volts, and then there's drops, 3 volts, 3 volts, 3 volts. If you add these all up and think of the battery as being positive and each of these light bulbs as being negative voltage, plus 9 volts minus 3 equals 6, minus 3 equals 3, minus 3 equals 0. So if you add up the potential difference for the entire loop here, you are going to get a potential difference of 0. Concept check. What happens to current in other lamps if one lamp in the series circuit burns out?